بسم الله الرحمن الرحيم. نحن اليوم خذينا الموشن ان 1 دي، وعلى الأقل نبغى نعرف أن نحن خذينا في الوضع الأفقي وخذينا في الوضع الرأسي، لكن بنربط ال 2 دي هذين اللي هي الأفقي والرأسي في حركة واحدة اللي هو مع الأفقي والرأسي. الأفقي خذينا عليها أمثلة. في مثال هنا بنعطيه على الرأسي، بحيث أنه لما نخش في ال 2 دي يبدأ عندنا خلاص مغطيين أن الأفقي بروحه والرأسي بروحه. تو حنشيل كيف ما تشوفوا العنوان الموشن ان 2 دي. في الصفحة 55 فيه مثال للحركة الأفقية، الحركة الرأسية، اللي هو فيه هنا يقول لك عامل أو العمال بتاع اللي ينظفوا قزاز العمارات هذول. فعلى اللوحة هذه اللي اسمها scaffold in front of billboard, فهي thrown a ball straight upward. أول حاجة الكرة upward بهالشكل بسرعة ابتدائية تساوي 11.2 متر بير سكند. إذن هي في عندها سرعة القذف الابتدائية 11.2 ملي سكند. The ball has an initial speed of 12.2. قال speed هنا يعطيك القيمة، وبينما الاتجاه اللي هو upward. إذن نحن ما زلنا نتكلم عليه velocity، قيمة واتجاه. When it leaves the worker's hand at the top of the billboard. كما في الشكل 2. What's the maximum height? Maximum height y maximum اللي تمشي لها البول. إذن هنا يبي الواي ماكسيمم. فطبعا لما نقول لك واي ماكسيمم معناها الفي النهائية تساوي 0. السرعة النهائية تساوي 0، لأن الكرة حتمشي لعند آخر وبعدين تبي ترجع بهالشكل. كانها وقفت في عند الواي ماكسيمم. و طبعا لو نجو نحن شنو عندنا هنا المعطيات. لما نقول لك given V0 is equal to 11.2 meter per second and V is equal to 0. Okay? What we have also, which is not given, but it's normally we know that the ball is free, then it has the gravity of the earth. G is equal to minus 9.8. Okay, of course, this is meter per second squared. This is meter per second. In this case, we have V, 0, V, and G. Then we have we'll use the law as V square is equal to V0 square minus 2GY. Here, at Y maximum, V is equal to 0. This is 11.2 minus 2 times 2, 9.8, and Y maximum. Y maximum. In this case, you say Y maximum is equal to 11.2 here square, of course. Okay, square divided by 2.2 times 9.8. You'll see here. I don't know. I didn't calculate that, but it's 6.4 meters. Okay. And now what's also ask, how long does it take? The word how long, that's mean asking for the time. How long? Be careful. There's not a distance. How long? That's mean what's the time? It's asking for the time. And of course, we'll select that the simple equation is V is equal to V0 minus A or G minus GT. In this case, here we have 0, 11.2 minus 9.8 T, and then T is equal to 11.2 divided by 9.8, which is 1.114 second. Okay. Then, okay, we got here Y maximum is 6.4 meter, and here is 1.14 second. Okay. And C asking what's the position? What's the position? What's the position of the ball? Okay. Of the ball at T is equal to second. Okay. Then we have two cases here. Either we say Y, okay, Y at T is equal to second, then Y is equal to V0 T minus half GT squared. And we have here 11.2, 2 second, half 9.8, 2 second square, and this gives you 2.8 meters. What's that? Now we have 2.8 meters plus. That's mean as 6. We have two cases here. If we say it's 6. This is all 6.4. Okay, and we have here positive because it's positive here. Then we have 2.8. Okay. This the rest here is 6.4 minus 2.8, which is minus 3.6. The ball comes here down 3.6 meters or plus 2.8 meters. This example is this is example 211. Okay, this is a case of vertical motion. Let's see, combine the two motions, in vertical and horizontal motion, which is in chapter 3, page 67. And the title, as I have written, it's motion in two dimensions. Okay, and it's in XY direction. In XY direction, and if we have the motion this way, making an angle of theta, Okay, we call, say, this is d, distance, whatever displacement, and it goes here at a point of x and y, like coordinates. If we say the coordinates of x and y, that's a position, a certain position, taking a certain x and a certain y. Okay. This distance was, say, in meter or whatever, and we have this triangle, and this is y, and this is x. D square, in this case, is equal to x square plus y square. Or D is equal to square root of x square plus y square. This is the length or the distance traveled. And we know, as we said, the vector is a value and direction. What's the direction? Is the angle here. And this is the slope. This is the slope. The slope is tan theta. Tan theta in this way, it's the y over x. Tan, we explained this, tan minus 1 is of theta is y over x. Okay. If we deal with the velocity, this is here Vx of t, and this here Vy, y is equal to Vy of t. Vx the same thing here. We say if this is a V, okay, this is the distance, and then this is the distance in y, and this is the distance in x. But if we say here V, okay, then also we have Vy and Vx. The same thing, that Vx is equal to V cosine theta, because here this is the theta, and Vy is V sine theta. Okay, this is defined in page 69. Let's see how to solve such problems. We have the example number 3.1. It says that if the slope of this diagonally, that means this, when they say diagonally, is that making a certain angle, okay? Diagonally moving ball. It's not horizontal or vertical. It's diagonal, okay? And this is the x, and this is the y. Okay. Has constant velocity of 0.5 meters. Constant velocity. Remember that the word constant velocity okay, of 0.5 meter per second at 37, this is the angle, relative to, the word is relative to x-axis, that means it's from x-axis, okay, from x-axis. Relative to y-axis will be this one. But here, this is relative to x-axis, that's from x-axis like that. Find how far it travels in 3 seconds. That gives me that t is equal to 3 seconds. And wants the d, of course. Okay? He wants that, the d, which is x squared plus y squared. And you have to get x and y in this case. Okay. Vx, let me do it here. Vx is equal to v cosine theta, which is 0.5 cosine 37. Vy is equal to v sine theta, which is 0.5 sine 37. Okay? That will give you 0.4, and this will be 0.3. Okay? Okay, now, taking x 0 as 0 and y 0, all starting here. X 0 is equal to 0 and y 0 is equal to 0. This is the origin, point of origin. Okay, then we'll say that x is equal to Vx t. Okay, will be Vx is 0.4 times the second, 3 seconds, the time is 3 seconds. Okay, that will give you 1.2 meters. And y is equal to Vyt, which is 0.3 times 3 seconds, which is 0.9 meters. Okay. Note that y or x is equal to x Vx t plus or plus half a t squared. But we use only this. Remember, when I said it's a constant velocity, that acceleration is 0, as we have done that on that graph. Okay? Okay, I have x and y, then d, as here, okay, d is equal to, where's that? 1.2 squared plus 0.9 squared. And that will give you 1.5 meters. This is the distance traveled. It's very simple. Nothing complicated, but you have to what you have and what you need. Okay, there are also, as you remember before, I gave you that the equations of the motion, and x and then ny as acceleration, and ny as acceleration due to gravity. The same thing here you find in page 71. X, y, and Vx and Vy. Constant acceleration only. Okay. A curving path vector component which is example 3.2, and gives you Vx0 is equal to Vx plus, is equal to Vx is equal to 1.5 meter per second. And Vy0 is 0. Ax is 0. Ay is point. Now we have Ay and Ax. Why Ax is 0? Okay. The ball is going there's a constant velocity in x. Okay, constant velocity in x, and we have here Vy is changing from Vy0 is 0 and so on. Okay, after 3 seconds, find x, y position, coordinates, as we say احداثيات x و y. اوكي، فلما نقول لك هنا النقطة هنا هذه x و y coordinates, as we have here. For example, we have 1.2 in x and 0.9 in y. For example, this is the point here called 1.2, 0.9. These are coordinates. This is the x and this is y. Okay, you have just you apply that since Vy is 0, Vx is equal to Vox plus Axt. You just apply for this. You have the V0x, and you have A is 0, Ax is 0. And the same thing here, we have Vy is equal to Vy 0 plus Ayt, and Vy0 is 0. While you have the acceleration of y, Ay, you have a value of 2.8, and the time also is 3 seconds. V, in this case, now we have Vx and Vy, and V is equal to square root of Vx square plus Vy square. Okay. All right. He applied the first law here. V is equal to V0 plus At. Okay. And we find Vx is equal to also Vx plus 0. Okay. But Vy is equal to Vy 0 plus At. We have this 0 plus this is 2.8. We have 3 seconds. Here we have 1.5 and this 0. That's why we have here what's 8.5, 8.4, 0. And here we have 1.5. Then V is equal to Vx square 1.5 square plus 8.4 square, which gives you 8.53 meter per second. Theta, because we have to have also theta. Now we are dealing with vectors. The vector has value. This is the value. This is the value. And we need the direction. Tan minus 1, okay, of Vy over Vx. Vy, which is facing this, and this is the closest to the theta. And then now We're given the theta now is tan minus 1, say 8.4 over 1.5 gives you 97.9 degrees. Okay, value and direction is the vector or velocity. Okay. Vectors. Also, let's take an example from ourselves here, and we have the v here, and we have the angle. Okay, I'll take this off. Let's see his drawing how, and I'll use the colors just to make things clear. For example, this here, sorry, it's dry. Vector A, okay, and then vector B, okay. Vector A, I have to put the head. The resultant of these two vectors, now we see this is the tail and this is the head, and this is the tail and head. We say that tail to head or head to tail direction. Okay, what's the resultant? Resultant starting from starting point to the end point here. Okay, R. This is that means it's vector. Okay, R is the resultant starting from starting point, ending at the ending point. Okay, and this we say R is equal to A plus B. Since they are in the same direction, then we add these vectors. Okay, if we draw, how can this happen? Let me put here for x and for y, and here for x and for y. This here is ax. It's not written here, but you have to follow like that, you know. I have here ax, and here we have bx. We have here also ay, and we have here by. And if we add, for example, here r of x is equal to, on this here, ax plus bx, while in ry is equal to ay plus by. We add here for this example here, okay. In this case here, r, the value of r is equal to the value of rx square plus ry square. Gives you the value of r. The angle here, the angle of r okay, this is the angle of R here, is equal to tan minus 1 Rx over Ry. Then we have the value and we have the direction. Okay? Please note this and try to remember, because it's not written here. Okay. If we have, for example, many vectors like that, we have one vector A, one vector B, one vector C. Okay, I want to make a graphical representation such that we can add and subtract these vectors. We'll say, okay, we'll say that A this way with this value, okay, vectors, and we say, okay, B the same direction, and so B, and we say here we have C. Okay, this is C. Okay, head to tail, and head. This is starting point, this is the end point, and this is here we have the resultant. The same thing, R is equal to A plus B plus C. Okay? Another thing we say, if we have, for example, C in another direction, or B in this direction, okay, B like that from tail. If we have that, this is A, and this here B, okay, and this here C. And our rule is head to tail, but this is head to head. It's not the regular representation of this. We say, no, sorry, B, okay, you have to be like that. You have to go like this. Okay? And I give you a negative sign. Okay? Such that to remember that your direction is this way. In this case, we find A minus B plus C. Then R, in this case, is equal to A, okay, plus minus B plus C. This is addition, this is subtraction in this case. As you go on, page 74 has also adding rectangular vector, and you have the value of C and the direction of C. Nothing changed, the same thing here. Many times we say AX, AY, BX, BY, so. But we have to represent the direction with unit vector. The books or the authors, they give different letters for that, or representing different from others. Well, Bufa here they give the a, small a, okay, in the direction of a. It's a unit vector. What's the unit vector? Unit vector of a here, like they gave it a and this small value here. That's mean the value of a is equal to 1. The direction of a, the same direction of a, the same direction, okay? Taking the same direction and the value 1, such that if you multiply 1 by any number, doesn't change the number. This you find in page 75, okay? And they represents like Cx. So we have to take this off. C, okay, C. This is C here. Now it has that Cx and it has Cy. Same, Cy here and Cy here, it's the same. He said that C is equal Cx in the direction of x plus Cy in the direction of y. Another representation. This will help us for analyzing the force direction and value. Now we have here many forces, okay? Let's see the drawing in page 76. We have also let's use the colors. We use the F here, F, which represent the force F1, like that, F1, and F2. Okay, F is equal to F1 plus F2. Okay, and F2 has a value of 2x, who has the value also of 2y. Okay, and here this is also F1x, and this is F1y. I presented like that, you know, but he preferred to I said F2 in y and F2 in x. He said Fy2 or Fx2. It's confusing also. And the same here, Fy1 and Fx1. It's the same. Yeah. Either or. Now, if this way, it has the value of Fy2 and fy1. Okay. And here fy, fx1, and this is fx2. And this is f. Okay. We have also here fx, take only the force in x, which is fx1 plus fx2. And fy is equal to fy1 plus fy2. And if the value of f is equal to fx square plus fy square, the direction is tan minus 1 fy over fx. Value, direction. Okay. If you have in the other direction, for example, f goes in the minus x or y minus y, then you add with the sign of that. Either it's positive or negative. And try it at home. The component of v, the method here, because you have vx3, it's negative, while vx1 is positive, and vy1 is positive, and vy3 is negative. Okay. If you want me to make it, we can do it, but I prefer to do it yourself. Make the sketch, see what's in the negative. Okay, you have positive x and negative x, and you have positive y and negative y. Okay. The same thing with if you get the cx, for example, or vx or fx, whatever, and bring also the cy, fy, then you give given that the value of f or v or so is the square root of the square in x and square plus square of y, and the theta is tan minus 1, the value in y over the value in x. Okay, the same thing you have here. It said that it's a rectangular and gives you that v and everything you have to put, because we have in 2D and we have x and y. Take all the x together and all the y together. Okay, add and subtract. أطرح أو أجمع أو أطرح. Then you have the values in x and the values in y. Square root of square of x and square of y. This is the value. Theta is tan minus 1, the value in y over the value in x. All the vectors in this way.